guys can start whenever you want.
Okay. You just edit the.
Yeah, we'll edit any video and all of the videos anyway. So
that's okay. See you later. Okay. So another 2 minutes and so.
Since there are not so many people, I would suggest maybe you move a little bit more up front.
I can hear you.
You're going to move the back benches.
His seats warm.
Okay, should we start anyway?
Yeah, I think we should. So we're going to move from IoT and modularizing your bundle itself to the cloud, which is also going to be a good segue into our next session, which is the cloud workshop. But we have the Cloudyle guys, Alexander Rezik. Rezik, sorry. Last time I did the same thing, right? I mispronounced your last name. And Torsten Frank talk about PaaS platforms and building OSGi applications in the cloud.
Okay, yeah, thank you for joining us today. Since we got the introduction already, I think I can skip this slide. Short information on the company. Cloudyle is the cloud branch of Medisight. Medisight is a company that is specialized in developing applications for the healthcare market, which we do for a couple of years now. And the agenda today would be that we talk about the steps towards our PaaS Plus, Platform as a Service Plus, and then talk a little bit about DevOps in the cloud and the OSGi Plus platform, and explain the modular enterprise APIs that are behind it. PaaS Plus is based on a research project which is called Tresor, founded by the German Ministry of Health and Economics, where the project aimed to provide a secure cloud infrastructure for healthcare together with other partners like the Deutsche Telekom, Technical University Berlin, and the German Heart Institute Berlin. So what are we doing? We have two things that are pretty cool. The cloud with the elasticity, reliability, scalability, and all the other benefits. And we have OSGi with its benefits like modularity, reusability, and concurrent versions, and all the other advantages. So what we do is we bring these both worlds together. Here you see the classical cloud stack. On the left side you have the traditional on-premise application where everything is on-premise and needs to be installed, configured, and so on. And as you come to the right side, you get more standardization, you get lower costs, and you get faster time to market. So you have the infrastructure as a service where some things are virtualized, and then you have the platform as a service where you have more virtualization, more standardization, and that's why we call it Cloudyle PaaS Plus, because we take the platform and add the OSGi framework, the enterprise API, and the bundle ecosystem, so that you get even faster time to market and even a little bit more standardization. And with this, you can build software as a service, which is on the lower right of the stack. So in the traditional development is you have to do a lot of things, you have to wait a long time until you actually can get going. In a cloud environment, you have your idea, you start code, you don't have to wait, you just start, you launch your application, and then you scale it. So it's much faster and of course much cheaper also. So how does this work? We have a very developer-centric approach. The developer works with his IDE, the standard known tools, and builds the business applications that the user can use. The cloud environment helps with the enterprise API, the bundle ecosystem, and does the scaling and the application development which is needed to provide the application and that the user can use it. The cloud provisioning works as following. You have the IDE again on the left side. You have the bundle repositories, a private bundle repository, the public bundle repositories, and you have the bundle marketplace where you can subscribe to bundles which are then brought to your private repository. Then the IDE will be used to push code, and the code will be built and deployed to the application runtime, and dependencies will be automatically resolved from the private or the public repositories. And since we are in the cloud infrastructure, you have the scaling, so if you have more demand on the application, you can easily scale up, and there will automatically be more application resources available. And you also have the nice possibility of a fine granular team workflow. Let's assume you have a developer. The developer has the domain where the development takes place. The codes will be pushed to the Git repository, a Maven build will be initiated, and it will be deployed again to the runtime. Then we integrate integration domain, where, for example, a Jenkins builder will take care of the build, and a build server will take care of the build and will apply, again, the artifacts to the runtime environment. Then there is a QA team which adds a staging domain. The staging domain will take care of the building and, for example, pushes it to the Nexus repository, to our repository. And finally, when QA has been done, everything is fine and can go to production, the operation team can take over and can run the production environment. So this is another view of the development lifecycle. Again, you have the developer that is coding, is pushing to the repository, automatically builds, either by a Maven build or a Jenkins build. The build artifacts will be published to the environment and will automatically deployed and can be used. Scaling works since we are in a cloud infrastructure. A little example for scaling. We have a little application, some users, and then the application gets hit, so you get more users. This will be detected by the environment, and the environment, the cloud infrastructure, can add more gears as the demand increases. So after a while, maybe at night, some users disappear and the demand is again low. So this is again something that can be detected by the environment, and some gears can be taken away so that it scales automatically as it's needed. So I've been talking about the bundle marketplace. This is where bundles can be added and subscribed, and this works as following. The artifacts that you have in your repo, you can offer it to the bundle repository, where they can be searched and found, and you can subscribe to the bundle repository as you need them in your application. And you also can get notifications of updates, and then can push the updates to your private repository. So you have the Cloudyle marketplace where this takes place, and it can be managed in the Cloudyle cockpit, the repository in between, and then your bundles can be used either in the cloud environment or in a local, for example, Karaf installation, or in any other OSGi runtime that you might use, or even in a system via different interfaces. Okay, Alexander will take over now and will explain some details about the infrastructure and the APIs. Hope there's time left.
Okay. Yes, this was the that we follow. I will go a little bit more deeper in the technologies beyond. What you normally have in your application box, you have a lot of different components, different flavors, different foods, and you have to bring them all together. You don't want to grow all your food by yourself, but not be able to do this. So usability, one of the main benefits of good OSGi modules, is a key point, and we try to strengthen this by adding some additional enterprise-grade APIs that could be used to build your application together. So what's behind our platform as a service technology? We base on the OpenShift technology from Red Hat. So this has several benefits. We can use a lot of the features of the OpenShift technology, scaling, specific deployment options. The tooling of JBoss can be used to also interface with our platforms, and we extend this by specific frameworks to add the additional OSGi stuff on top of it. This is an overview about the frameworks that we currently support. Some of the standard frameworks like Tomcat or Node.js could be used, but the main benefit comes from the additional OSGi stuff. We have a Karaf available for cloud deployment. Then we added repository features with the next repository, which can be used as a Maven and OSGi bundle repository. And we have several databases, and specifically we have also an additional Elasticsearch feature which allows you to integrate search engine and indexing your data in an Elasticsearch framework. This was the framework level which you can choose to build your application infrastructure of, and what we now have in addition for OSGi applications are our OSGi Enterprise APIs. So we thought about common use cases that you often encounter when building enterprise applications, and try to build some APIs that support for these use cases, make it easier to use. Make it easier to use, for example, to use JPA or reporting, where there are already powerful frameworks, but they're quite complicated to use, and we are trying to make some easier APIs for them and integrate these into our enterprise APIs for fast usage. They're all available as OSGi-Services, so they are simple to use, have defined interfaces, and could be deployed in an OSGi runtime easily. And on top of it, we tried to add some additional features to make some things a little simpler, to add some business logic that could help using them. That's a basic overview what we have available in our API stack. We built all on an Apache Karaf core with existing features. Everything that's available for Karaf you can also use in a cloud environment there. And then we have our enterprise APIs for certain use cases, and on top of the generic APIs, it's possible to build domain-specific APIs. We are building something for the healthcare domain, a project that we are doing, but it's also possible to have other domains supported, to have reusable APIs that can be made available in the repository, and then your business applications developers can use them to build your business applications faster than developing all the logic from scratch. So we're going to build on the details what our generic enterprise APIs do, what they offer. The first thing is our persistence service, which basically is some encapsulation of the JPA specifications. We have an areas JPA fork that we use. We added some additional features. We have full JPA 2.1 support, and we added some additional things to add custom properties from config admin files to configure your persistence unit during runtime. We use an Eclipse link or AMP framework, which adds us NoSQL support and composite persistence units, so you can mix NoSQL and SQL units with the same interface, which is quite nice. Persistence service gives some add-on features, so you can use the entity manager to add some additional features. It's often used in enterprise environment. So we have some generic cancellation feature, which just have to add an interface to your entity, and it's cancelable. So you now don't want to delete an entity, a business entity, but you want to cancel it because the data should be stored for further usage. We have an audit trail functionality to make versioning in the database available, and have the ability to plug in additional extensions on the persistence layer, for example, indexing or a type-safe query mechanism that allows you to build your queries inside your code without writing string queries, which are often error-prone. One of the nice features that come with the Eclipse link inclusion is a composite persistence unit, which makes it possible to have different low-level persistence units for different databases and combine them in one persistence unit, one entity manager for transparent use. So you have NoSQL, for example, you can mix NoSQL and SQL database with one entity manager. So you have entities in one or another, but the using bundle doesn't know about it. Just use the entity and it's stored automatically in one or another database depending on how it's designed. So you can then structured data, relational data in a relational database, and document related data in MongoDB, for example, and access them and reference them in the entity on the entity level as they are in the same database. For configuration, it's also often a thing that you use in your applications, some user-specific configurations or application-specific configurations. We implemented the OSGi preferences specification and added and have this available. The storage is also done in a database, so it's we have persistent storage for these configurations, and due to the specification, we have the ability to have a configuration tree, so we have configurations that build up onto each other. On the business level, we have a business process engine integrated. It's a business process engine from Camunda, the former activity project, which gives us all the interaction on an OSGi-Service level. So you have OSGi-Services for interacting with the processes, and you can even deploy your processes as OSGi bundles, and then they'll be available for your process engine. And from the process, you can access other OSGi-Service and therefore make your business logic more flexible than hard-coded. It's a full VPN2 business process engine, so all the features that the VPN2 specification has is available here and can be integrated as a feature in the OSGi environment. Our user management service is more complex because it builds on a full-featured IDM system from Midpoint, which is a further development of the former Sun IDM system, which allows you to access identities from different sources, from LDAP, from a database, from custom application, from an Active Directory, from Kerberos. So it allows you to plug in different identity sources and manage them from a central API and from a central user interface. We have an OSGi service API that interacts with this Midpoint core to allow you to manage also users and access user data from your OSGi application. I mentioned already Elasticsearch. We have the ability in our PaaS platform to start up an Elasticsearch cluster and scale it up. And with an OSGi service, we are able to access from application via an OSGi Java API with Elasticsearch clusters. You can index your data, you can query your data, and we have a specific integration with our persistence layer, which allows you to, just with some annotation on your entity, to index certain data while they are stored in the database. So you can make for faster queries, index some of your data, and use the query service to search them via Elasticsearch, and then they're automatically loaded from the persistence. So it brings both storage types together and allows. We have therefore the mixing of an SQL database, of a MongoDB, and Elasticsearch in one setting without an interface. Some other service that we have is reporting and catalog support, reporting for PDF generation. We integrate Jasper reports in the OSGi environment and also added dynamic reporting functionality, so you can create reports on templates or dynamically from your code and makes the interfaces for them easy to use for the common use cases. So you don't have to dive into the deep depths of Jasper reports for creating reports. And the catalog service is on business logic on the persistence layer that allows you to define catalog structures and make typical catalog searches. But often in business applications, catalogs, either from some standards, in medical you have medication catalogs, or in your business layer of product catalogs, and this allows you to define standard catalog structures and search different versions of catalogs and use standard code-based catalogs easier or faster to use than to implement everything on your own. For the web layer, we support, we have a web UI framework. We integrate the Vardin web framework, which is a rich web application framework which has a lot of available components which have much functionality and features. It's based on Gibet WT, and we added additional OSGi support, some framework which makes it, which gives you standard layouts, so you can easily start your web application. You just have to implement your really views and can then put it together. We have a login, standard login available. We have standard layouts, so it's possible to use Valiant components to build your application without focusing on the gluing stuff. What's an application without security? Security is a important topic. Also there we integrated a well-known solution. The Apache Karaf project is the base of our security solution. Integrated in our OSGi environment. Can be used for authentication. You have it's also integrated in our web framework, so you can use a login which connects to Shiro. Container configuration uses different identity providers to authenticate your user or our user management available. You can also use the authorization features of Shiro. It has some annotations where you can protect methods with permissions and roles and so on. And with the Blueprint extension, it's possible to take this outside your code and just say these methods are protected with annotation, and the Blueprint automatically injects the interceptor and checks the permissions during runtime. In addition, we have used bundle security to further limit and restrict the possibility to use the APIs in a more open development environment. It's possible to say, okay, certain APIs are can only be used by trusted bundles or something like that. So summarizing, what benefits we offer for development OSGi Application Cloud. We have available a self-service on-demand platform, which it's possible to start applications, OSGi applications directly in the cloud. Therefore, the process for starting up the framework and so on is much lower. You just start and start coding and get more productive faster. With the enterprise APIs, our target is that the business developer can focus on their business stuff, and the standard stuff could be reused. So it's possible to develop applications faster. Specifically, you have also domain-specific APIs available that can reuse and reuse. In the same environment, you can have build up a team workflow with a test environment, a staging environment, a production environment, and all interact with standard tooling. So it allows you very easily also if need increases, we have another development team just set up another instances for starting development fast. With the cloud features, latency and scalable ability, the applications you put in production can scale automatically. Karaf, for example, can also enable a seller clustering if needed, so you can replicate your changes easily to different instances of your application. Yes, the application portability due to use of standard APIs of OSGi should increase, and with the modularization of OSGi, we think the decrease of complexity and the increase of the use is a concept for OSGi that helps for building better applications. If you're interested, we have early access available on our platform at cloudyle.com. They can sign up for free, try it out, give us feedback. We'll be happy for this. That's all. I think we are good in time.
Okay. Yeah, we can have we have a few minutes for
some questions maybe.
I have one. So, do you guys use and manage your own infrastructure, or do you use third-party infrastructure for your building out?
This runs on Amazon.
Amazon. Okay.
Mostly can't. But basically, we are independent of infrastructure and could deploy on other infrastructures. For example, for our project we mentioned in the beginning, we host this on a telecom, Deutsche Telekom infrastructure. So we are flexible there.
Any other questions?
Okay.
Well, thank you,
Thank
Johnson
you.
and Alexander. So, the next session is the cloud workshop. So if you're interested in cloud, please come back. It's going to be very interactive. So, including you too.
We stay here.
Yeah, stay here.
We stay here.
Okay.
Thanks.
So I one request. Do you have a PDF of your presentation?
Yeah, okay.
just-
So, 1 minute, I have to restart my PC.
Oh, okay.
I just
So-
generate your PDF.
Right.
Yeah.
If you can, yes, we will put it on the website.
Yeah. Yeah. Das ist ein Nachteil Windows. Apple würde das nicht passieren.
So when was the company launched? Was it very recent? When
The
was
company was launched spring,
Oh, okay.
so we pretty new and yeah, building it up.
No, we spoke last year a little bit also about the CAMP
Yeah.
standard.
Yes.
You sent me some information, I looked at it, but I was not able to go much deeper in it. We still had one on our agenda to add some provisioning interface based on CAMP, but it's it was delayed a little bit our progress there.
Maybe
We were
Now
still
it's-
working on it. We are almost done with 1.1.
Yeah.
We're thinking about what should we do next. So we're looking for feedback and
Yeah.
people to try it out. And so CAMP is now being implemented by OpenStack Sound. And as well as there's a new Apache project called Apache Brooklyn, which also has a CAMP server. So the hope is that if you have a common management API for PaaS platform, then it's managed, everybody has to do it, everybody kind of does it in the same way. But they all do it differently, in different ways, and so there's no interoperability, there's no portability, like write scripts to monitor your applications, and it's everything is different depending on which PaaS platform you go to.
That's right. So you get more interoperability and
Right, and nobody, it's not really a value add to your PaaS platform. Right? You need a management API, but people aren't necessarily going to use your platform because you have a great management API. Right? They're going to use it because they like Apache Karaf and they like the features that you offer, maybe the price and the combination of the two. So it's sort of a low-hanging fruit for standardization.
That sounds good. Yeah, we recently also joined the OSGi Alliance, but still didn't have time to really get into more participation. We also wanted to promote. It's a very interesting field. I think it's there's a lot of improvement, a lot of going also with the internet, ICT things.
Right.
It's very fun.
So how big is the company?
We are about 20 people.
Oh, okay. It's reasonable. Nice. It's not recognizing?
It's not recognizing. I have some problem with my USB ports. I don't know what's it's not always recognizing. Ja, ich muss nur ein bisschen Code finden.
Yes.
Supposedly, but he answers
Vielleicht auch noch zu langsam, oder? Irgendwie.
It's not working? Oh, you can email it to me.
No, it's working.
Oh, it
Just takes.
It's Windows.
It's just Windows.
It's good to have everyone here to start, but then when the breaks on, then every
Ha.
there you go.
Just everybody USB ports wants to detect it and then it works.
It works eventually.
Oh, Anna, this one.
Yeah. But it's hopefully IoT stuff as well. And it's the whole, what people want is again, what's changed. This is what we've got, lots of ours, we're going to take it,
Thank you so much.
Thank you.
So it's interesting. I mean, it's interesting to see how it's developed. Yeah, talking about this stuff for quite some time. So it's interesting to build in some direction, isn't it? Certainly nice to see the JPA stuff getting some proper exercise with us. Because a lot of people just sort of play with it and go on.
Yeah, that's been one of the group last year. Started.
kind of.